We want to come up with a graph of h of x equals x squared minus 9 over x plus 1. And our first step is to identify the zeros. That's going to happen when the numerator, x squared minus 9, is equal to 0. So we just solve this. Take square root of both sides, and x is equal to plus or minus 3. That means we're going to have two zeros, one at positive 3 and one at negative 3. Next, we want to take a look at the domain, and what we have to worry about with any rational function is that the denominator, x plus 1, cannot equal 0. So that's going to mean that x cannot equal negative 1. And we'll have a vertical asymptote at x equals negative 1. Third thing is to look at the limit as x approaches infinity of h of x. And since x is getting extraordinarily large, that minus 9 and the plus 1, I mean, when we're talking about infinity, a huge number, if we take something that huge and subtract 9, it's like we didn't even dent it. So the only thing that really matters is those leading terms. So this limit is going to be the same as taking a look at the limit as x approaches infinity of x squared over x. And when we simplify that, we get the limit as x approaches infinity of x, which is infinity. Right, so this limit is going to be infinity. That causes a problem for us. It means that we will not have just a vertical and a horizontal asymptote, but this second asymptote is going to be oblique. So we need to go back and take a look at h and rewrite it in another form, and I'm going to do that using synthetic division. Since I have x squared minus 9 in the numerator, I'm going to take the coefficients 1, 0, negative 9, and I'm dividing by x plus 1, so I'll take the root of that, negative 1. And we just bring down the 1 and multiply and add, multiply and add. So I'm going to multiply by negative 1 to get negative 1. Add those two together. 0 plus negative 1 is negative 1. Multiply again by negative 1. Now it's positive. And then add those two together. So I'm at negative 8. That means that we can rewrite h of x as being x minus 1 plus negative 8 over x plus 1. Okay. Now, since an asymptote is the line that the function approaches way out at the extreme, so like as x gets bigger and bigger and bigger, we see that this fraction, negative 8 over x plus 1, as x gets extraordinarily large, that fraction is going to get very, very small. And so that means that h of x is going to look like the line y equals x minus 1. So that's going to be our oblique asymptote, y equals x minus 1. In order to graph it, I'm going to move down a little bit. And we'll start plotting all of our important information. First of all, we have two zeros. One of them's at 3, and one of them's at negative 3. And we have a vertical asymptote over at x equals negative 1. And the horizontal asymptote is the line x minus 1, y equals x minus 1. So that would give us a slope of 1, so something about like that, and a y-intercept of negative 1. So we graph all of that. That kind of sets up all of our boundaries. And in order to identify where the graph is going to be, we want to kind of check out a sign chart. So we take another look at h of x, and since our numerator is x squared minus 9, that's going to be x plus 3 times x minus 3, and the denominator is x plus 1. Then we make the sign chart. So if I pick something less than negative 3, like negative a billion, we'll have a negative factor times a negative factor divided by a negative factor. So the entire fraction will be negative. In between negative 3 and negative 1, so something like negative 2, that will, negative 2 plus 3 is now positive, but negative 3, or negative 2 minus 3 is negative, negative 2 plus 1 also negative. So now my fraction has become positive. Then in between negative 1 and 3, we pick a number like 0. 0 plus 3 is positive. 0 minus 3 is negative. 0 plus 1 positive. The entire fraction now is negative. And finally, we pick something very large like a billion. Billion plus 3 is positive. Billion minus 3, positive. Billion plus 1, positive. So the entire fraction is positive. And this is enough to come up with our graph. Because we need to stay close to the asymptotes, I'll start on the left. We're on an interval that's supposed to be negative. So I'm going to go from my 0 down to my asymptote. And then after that, we stay positive and get close to that vertical asymptote. After we pass over -1, we have to be negative again. So we'll go on the other side of the asymptote and get to the 0, and then up towards that asymptote. And there we have a rough sketch of what h of x will look like.